Just want to welcome everybody to the Tools to Boost Your Manufacturing Operations session. It's going to be a fairly quick one, so if you guys have questions, feel free to post them in there. I've got Chris Cook joining me. He's on the background, or in the background. They'll be able to answer any questions if you guys drop those in the Q&A, as well as kind of monitor the entire thing. So welcome, Chris. Welcome, Charles. Welcome, Jordan. But let's go ahead and get started on this. So what I have for you guys today is really a presentation. It's going to be fairly high level. I'm not going to get into the clicks and picks. I'm going to be covering a lot of the different software solutions and kind of how you can leverage them and use them in your business to complete, the entire process from design through manufacturing. So to start this off, really just a general roadmap. I've got sections on the engineering, design, and release. I've got a section on manufacturing planning, and then the operations, which is, the machinist actually running the CNC machine. As I said, we're going to hit on a bunch of different software solutions from PDM to SOLIDWORKS Manage. We're going to, talk about SOLIDWORKS and some of the different workflows you can use there. Some CamWorks and some of the other products that are available with CamWorks that you might not be aware of, the Predator software, and finally Eureka. So first thing before we actually get into the process, what I wanted to kind of make you aware of is because we are going to be using PDM and Manage to kind of work from that, or to achieve that single source of truth environment, is some of the differences between SOLIDWORKS PDM workflows and Manage processes. So, hoping that most of you are aware of what SOLIDWORKS PDM is. Really it's a document control software. You get capabilities, extended capabilities for searching, controlling securities on those files, managing permissions, as well as workflows and automations and such. But specifically, the differences between workflows and managed processes are going to be PDM is always file-based. So every file that you save into the vault is going to be associated with one and one only workflow. PDM workflows think of them as being used for very simple cyclic processes. So things like incrementing revisions, where manage processes are a terminating process. There's a start and there's an end. And if you need to do that, say, operation or procedure again, you would create another instance of that process. They are also object or item based, meaning that you don't need to have a file created. So for a lot of tasks that people get assigned, there aren't associated files, and using a managed process, we can track the status of that task or process by using managed processes. So coming back to kind of our general roadmap here, I'm going to, obviously talk about the roles of a bunch of different people here. So we'll have, an engineer, a manager. In the manufacturing planning stages, we'll have, an NC programmer, and then finally we'll finish up with, the machinist and how he can actually run the machine and get the part manufactured. So starting off in the engineering, design, and release stage, we'll have Dan the designer and Megan the manager. Some of the tasks that they get assigned or that they need to accomplish are going to be, first designing the part, right? Part or assembly we're going to use for simplicity's sake, just a standard SOLIDWORKS part. They need to review it and approve it, and that's where Megan's really going to come into play. And then one thing that I'm going to throw in here is creating a CAM part, and I'll talk about that in a little bit, why we would maybe want to do that. So first, kind of again, hitting on PDM, your standard workflow that companies will use is just in PDM. Here I have just a simple workflow setup that uses a work in process state, a review state, and a release state. And it's very common to work out of just Windows Explorer. Right-clicking, changing the state on that file, moving it from that work in process through review to the release state, while realizing all of the other benefits that you get out of PDM. Before we get into the automation side of it, I mentioned I was going to talk about creating the CAM part. And so, a very common way that people will work when they're using CAM software is to just use the engineering file, insert it into an assembly, and then program the part off of that assembly, just a single part into an assembly. And that works. And the reason that they'll do that is to create a separate file. I was a designer. It's kind of a touchy subject when you're giving people permissions to edit, the native file, you could say. And so, creating a new file gives them some abilities with assembly operations or assembly features to remove material for, say, if you had like an anodizing that added thickness, well, you would have to, have your original start part reduce the thickness of that component to whatever the thickness of that anodizing is, so that when you go through that anodized process, the engineered part and the final part dimensionally match. So, creating an assembly is one way to do it. The way that I would typically recommend it, though, is to create a part. And the way that we achieve this is just using a simple insert part into part. Creating a cam-engineering part from that engineering file will achieve the associativity, the same relationship that you get with an assembly. Although now we have a SOLIDWORKS part that we're going to use for our programming. So we have all the benefits of using all your standard part features in the SOLIDWORKS environment, adding, removing material, whole wizard stuff, etc. Giving the machinist, the capabilities to manipulate that geometry however he or she needs to for the machining purposes. Some of the other things that you get with PDM are going to be the automation. And so a common case here would be, when that file goes from work in process to review, Dan might want to notify or let Megan know that, hey, this task needs to be done. So, standard PDM, you can do a Windows notification. You can also send an email. I don't know about you guys, I get a ton of emails, and if you look at it, it's not something I'm going to do right now. Typically drag it into a folder, and that could get lost. Right? You can also do other automation things like creating that CAM file. So SOLIDWORKS PDM Professional does have a full API. And so, those simple tasks, anything that you're doing repetitively over and over, I recommend looking into getting a script created for that. And you can instantiate those scripts or those tasks through different transitions. So in this case, when the file goes from a review to a release state, it could automatically recognize files that, say, for example, had a built or purchase. If it was a built component, it would automatically create that CAM file doing that insert part into part feature. So you don't have a user having to manually do that. Talking about managed process, where does that play into this entire thing? With SOLIDWORKS Manage, you can connect the process to the PDM workflow. An example of that would be here. I just have a simple process put together, diagrammed out with some swim lanes here, where I have the engineer in the first swim lane, and then the approver or the manager in the second one. Well, when that engineer finishes his design task, he needs to submit that for approval. And working through Manage, you can just select on that that process and say move it to the next stage in the process. When he moves that to that review design, SOLIDWORKS PDM will automatically move that file to the review state. So you don't have to try and manage them in both environments. You can use Manage to progress files through the PDM workflow, but then also realize all the benefits and advanced functionality you get with the managed processes. One of those specifically being task management. So when you talk about SOLIDWORKS Manage, there's really 4 main items. There's going to be dashboards and reporting. And so in this case, when we're creating tasks, when you fire at Manage, you can have the user, when they log in each day, have a dashboard that has all their tasks with due dates and Gantt charts, the current status of those tasks, a whole bunch of different things. I'd highly recommend looking into that if you don't have anything in place to manage that. You can also do, I mentioned task, project, and task management. We're talking about and processes here specifically. So as that file goes from submit for approval to review design, there's a task that's actually created for Megan, the manager, that, hey, you need to do this. It's right on their dashboard, so that never gets lost and is visible to anybody at any point in time, so they can look and see what is the status of this without having to send another notification email or go walk over there, tap her on the shoulder, whatnot. Another example might be when this design is released or completed, they could notify the programmer, which would create a task on their dashboard and assign it specifically to them, letting them know that that work has to be done. Or one other that would play into this this process would be as if there's changes required. Say Megan doesn't like the design and wants to get a redesign of it, she could just reject that, and then Dan, the engineer, would have a task on his list again. Hey, Megan rejected this, you need to update the component or redo the design. So just real high level, some of the things that in that engineering release, I hope that, or I think that we're all familiar with PDM, and really PDM is a document manager. It's the status of that file. But when you start talking about some of those more complex processes, a lot of times they aren't enforced or they're difficult to follow. And that's what Manage can do for you. You can build those processes out and force people to follow them, as well as getting the benefits of creating real-time tasks that are associated with the documents and making everybody aware of what the status is at any point in time. Moving on to the manufacturing planning side of it, we're gonna, now Debbie's got this task, that file was released, and so some of the things that she needs to do are, create maybe a CAM setup. If we've got a machine that requires fixturing, how is that done? She's got to do the NC programming for it, create your operations and tool paths, define your machine, what are the tools that you're going to use for it. Maybe she wants to do some simulation, and so we'll talk about a solution that we have that allows you to show the entire machine simulating to make sure that we don't have any collisions or interferences, etc. And she also might want to create instructions for the machine operator, something like setup sheets using exploded views. And what software, what tools we have to make that job easier for us. So moving into this, I guess I didn't mention before, what I'm going to do throughout this entire presentation is kind of keep track of the files that are being created and then how they're used. So you're aware of how those are being managed and how you can keep track of them. So here, in the case that we do need to create a CAM setup file, if it's just a simple part, you might not need to. But if it's something that requires any type of extra jigging or fixturing, etc., what we would do is take that CAM part that was created from the engineering file, so there's that relationship, and simply insert that into an assembly. With that assembly, then we can add, any of our fixturing components, design around it, whatever we need. But now we have our entire setup in a file that's associated all the way back to that engineering file. So if any changes are ever made to that, all those updates propagate through the entire chain. Once we have that setup file created, we would then move into the CAM software. Now there's SOLIDWORKS CAM, I think that was released in 2016. There's also CAMWorks, which is a gold partner of SOLIDWORKS. It's a full-blown CAM software. And so right directly within SOLIDWORKS in the add-in, you go through the process of defining your machine, you define your operations, doing some feature recognition there with the actual solid model. You write your tool paths, and then you would export your NC file. And that's just going to be, a text-based file with all of your G and M code on it that the machine controller is going to use to, actually cut that part out. So now we've got, another file in our library that's, I just gave it an arbitrary name, NC CAM setup.txt. The next stage, or the other task that we needed to complete, was maybe the machine simulation. And so a software that's available for you guys that you might not be aware of is Eureka. What it does is it's a virtual machining software. Some of the benefits from that is you actually take the entire machine, you can insert it in there, take your assembly setup, set that up how you want, and you can get the full machine simulation. So for simple, 3-axis mill components, you might not need something like this, but when you start getting into some more complex 5-axis or mill turn machines, there might really be some benefit to seeing how the entire machine is progressing through the different operations it needs to, and getting that validation that it's doing what you want and that there aren't any interferences or collisions, etc. One of the things worth noting here is that it is actually the Eureka virtual machine, is reading directly from that G code. So it's been around a long time. It has all of the controllers defined in it. So what it'll do is it'll take that G code, you can do the post-processing on it and then simulate it how it would with the actual controller on the machine. It's reading through that G code versus the simulator in CamWorks or SolidWorks CAM is just going through the different operations and toolpaths that you've defined. But there can be some translation, or there will be some translation from that original NC export to whatever language or version of that code that the controller needs. And so here you'll be able to virtually simulate the entire file, or the entire operation. One other thing worth noting on this is it is a paid software for being able to create the simulation file, but then the viewers are free. So if you had one person that was doing the programming or the simulation, they could publish that file on in the vault or somewhere in a location accessible to the shop floor, and you could have the Eureka viewer installed on all the different shop floor computers, and they would be able to open that up and view it at their own discretion. Here's just kind of a simple example of that. So you have the programmer that's in the office doing the programming, and then Carl, say he's got a tablet out on the shop floor, right? He's able to just open up that EPF or that Eureka simulation file, view it, validate it, and then move on with his next task. In terms of setup instructions, I was talking to one of the guys on our manufacturing team the other week, and he was explaining what is actually CamWorks shop floor to me, and what resonated with me was SolidWorks Composer. So those that aren't familiar with Composer, what that allows you to do is repurpose or use the SolidWorks files and create things like assembly instructions or maintenance procedures. It is linked back to the CAD, but you're never going to, it's a single directional relationship, meaning that you read it in from CAD into Composer, and then you can make changes, hide, show stuff, do exploded views, etc. But nothing you do in Composer is going to ever affect the SolidWorks or the CAD files, the engineering files. If there are changes made to those engineering files, you can just simply go back into Composer and run an update, and all of the views that you've created in Composer will update from those CAD files. So you don't have to go through all of that work again, creating all those different exploded views, taking screenshots, adding them to Word documents, etc. And the software that we're going to talk about here for doing the setup instructions for manufacturing purposes is this CamWorks shop floor. So there's two different versions of it. There's a publisher and a viewer, but it's essentially a very similar thing to Composer, where you would take that CAM setup assembly, you would read that in, you could create all of your different instructions in this CamWorks shop floor, and then you would publish that as a CWSPFLR file that you would then be able to open up on the viewer. This viewer is a complete CAD viewer. So if you kind of like e-drawings, you can rotate your model around, you can view any critical dimensions. You can also view all the different CAM operations and toolpaths and step through each one of those as you would in the CAM software. And also included in that, it's like a digital container. So if there were any other associated documents that you needed to do, you could just simply add them to this CamWorks shop floor file, and then out on the shop floor, the machinist would be able to, on his tablet, or if there was a desktop computer out there, whatever, be able to open up this CamWorks shop floor viewer and have everything accessible to him that he needs to set up the machine and to run the part. So then where do all these files get stored, or how do they play into this? How do we understand what they're associated to? And something that I had done in the past was, in PDM, you can do the copy paste as reference, but that's a manual process, and it can get very tedious and cumbersome, and may or may not get done depending on how busy or lazy different people are. And so one of the benefits with Manage is, as I stated earlier, it is an object and an item based system. So in this Manage process that I have defined for the planning stages of our overall process, I simply have the start, which is the task being created from engineering. We have the create cam setup if necessary. We have programming the part. We have creating that machine simulation. We have creating the operator documents or the setup documents with the CamWorks shop floor. And then this stage of that, overall process is complete. But what we can do is, because this is an item, we can associate each one of these different files with that item in SOLIDWORKS Manage. So you'd have a full history of what stages this item or process went through, and then what are all the associated files with it. So anybody at any point in time could say, okay, we got a request for job number 1, 2, 3, 4. This is the first time it's been done. You open up that item, here's the NC code, here's the virtual machine simulation, and here is all the setup documents required to run that part, all tied together, in one item. Very easily accessible and visible to anyone that needs it. So that kind of wraps up the manufacturing planning stage. We talked about how we got the request from engineering. We used SOLIDWORKS to create that setup file, adding in our vise or tooling or fixturing, whatever we need to mount our workpiece, using CamWorks or SOLIDWORKS Cam to actually define our operations, define our tool paths, and export our NC code. Using Eureka, we can actually simulate the final G code that the machine controller would run, as well as include the entire machine to make sure that we don't have any collisions and that everything is running in the way that it should. And then finally, we talked about CamWorks Shop Floor, which is that digital package of everything that you need to do that setup, what your tool crib is, or what tools you need, different setup operations, being able to use it as a CAD viewer, so the shop floor doesn't need a version of SOLIDWORKS installed on their machine, as well as being able to step through the different operations and tool paths right on the shop floor while they're standing at the machine to verify everything before they run that part. So let's, I guess I haven't checked the questions here. Looks like Chris is hopping in, talking a little bit of Manage. Appreciate it, Chris.
Yep, we've just been following with chat. I haven't seen any questions come in yet.
Okay, awesome. Yeah, if you guys have questions, like I said in the beginning, feel free to fire them over there. I'll hit on them here at the end as well. We're going to have a little bit of time. So love to answer them right away. So once we finish that manufacturing planning, then we move to the operations, or the actual doing the machining, creating that physical part. And this is going to be tasked to Carl. Some of the items that he needs to complete, would be, if we created that simulation, he has to review that simulation. He's got to set up the machine, go get, his tool bench set up, get the machine all, get the part fixtured in where it needs to be, and then actually run that component. And so how is he going to do that? So for this, I created, a separate manage process, which is again going to be that item, same as the other two. And he's going to get the notification, the task from the NC programmer that, this part is programmed, all the setup documentation is complete, you're good to go ahead and start setting it up and run the part. Some of the things that he might want to do would be reviewing that simulation, make sure that he agrees with how that programmer had set everything up. He needs to set up the machine and he needs to run that part. So how is he going to do that stuff? You can see, on the left here, I populated what files we all have created. And so out on the shop floor with his tablet, he would literally just fire up that Eureka virtual machine viewer, open up that EPF file, and be able to run through that. He could then simply open up that CamWorks shop floor viewer and review the entire CAD file, review the CAM operations, toolpaths, look at all the setup sheets without having to carry around a traveler, flip through a bunch of different papers that aren't documented, just view everything digitally, virtually there that's connected back to that original file. And then finally he has to run the part. And so, typically what I'll hear or see are people running around with a bunch of USB drives, plug it into a server that's connected to, the main vault. They'll copy and paste that over onto the USB drive, run out to the machine controller, plug it in, copy it over, and then review the G code on on the controller on the CNC machine. This is where the final piece of software that I want to talk about is Predator comes into play. A bunch of different modules to Predator, some really cool stuff that I recommend you guys go check out and review if you're having anything that's not connected in your manufacturing operation. But specifically here, with Predator DNC, there is integration to SOLIDWORKS PDM. And so to send that machine file or the G code to the machine, you can just simply right click in PDM and say send to machine. It'll give you a list of all of the machines that you have connected, and selecting the appropriate one will allow the machinist to be notified, hey, this is on the machine, just go over to it, pull it up on the controller, and we're ready to go. So there's none of the running back and forth, creating duplicate files. It's all connected to that single environment. So that was kind of all I had for you guys. We ran through, from design through manufacturing, talked about the engineering, design, and release, and how, PDM is kind of that good, and bringing manage into it. We can get to that better and best, leveraging some of the task creation, how it's connected to PDM, how we get into the manufacturing planning, how we can leverage some of the CamWorks solutions, Predator, Eureka to do some machine simulation, to create our setup sheets, all at the same time using managed processes on the back end to make sure everybody is aware of what's going on in real time. And then finally completing that machine, talking about having digital computers or tablets out on the shop floor to be able to reference those files and see what's been done without creating duplicate files, which, I'm sure we've all run into the scenario where they don't match, and then which one is right. If we're all pulling from the same source, you got that single source of truth, and everybody is aware real time of what's going on.
We had some questions come in, Andy, and one of them I just accidentally clicked that we had answered it live, and we hadn't answered it yet. But okay. That was from Carl. He asked if Manage was able to help with the ECR ECO processes and help create ECR numbers, along with giving tasks to those needed for particular sign-offs and project examples.
Yeah, absolutely, and that's one of the core features. I guess a lot of the material that's out there right now is around engineering change processes for Manage. There are some elementary capabilities in PDM to do it, but because a lot of the stages through that process don't have an associative file or multiple files, that's where Manage really levels that up, and you're able to define that process. So I've got my contact information here. Feel free to reach out. I can shoot you guys some references on that, but absolutely Manage is the tool for doing and defining engineering change processes.
Yeah, as a matter of fact, it has an integration into Outlook. So you can actually send an email to the system to start an ECR, which is pretty interesting.
Awesome. Was there anything
I have another one from Jordan. Would SOLIDWORKS Manage be capable of integrating with a counterpart-based shop system?
I'm not 100% sure what a counterpart-based shop system is.
Counterpart's like kind of like an ERP system.
You want to take this one?
I'm vaguely familiar with it, but I'm not sure on the integration side. I know they've written the ability to integrate both with PDM Pro and with Standard, because they aren't leveraging the API. They're doing it a different way. So it's possible, but I'm not entirely sure. I don't have a definitive answer on that one.
Yeah, hey, and so Jordan, why don't you shoot me an email, or if you have another contact here at Hawkridge, feel free to reach out, and we can do a little bit more digging on that and get you a more definitive answer. More than willing to look into that for you. Any other?
And there was one that I answered in the chat, which was, is Manage part of PDM, or is it a separate package? And so.
Okay, yeah. So SOLIDWORKS Manage is a separate package. Manage does come with PDM Professional, but if you currently have PDM Professional, it is an additional purchase on top of that to get those more advanced features.
Yeah, basically you can upgrade your licenses for the difference in the cost.
Yeah. Awesome. Well, it looks like
another question.
What? Sorry, go ahead.
Oh yeah, Joshua asked. So is Manage has its own API? Not yet. It is in the works, but it's not publicly available just yet. But it does so much through configuration that you know, initially they thought maybe an API wasn't even going to be necessary, but you know, we're resourceful enough that we proved them wrong on that. But so it is coming.
Awesome. So, okay. That looks like all of the questions. I want to thank you guys again for joining, and also if you have questions, feel free to reach out. It's stuff that we love doing. If you have unique challenges, we'll see what we can figure out for you.